In this video, I'm going over our Quiz 3 practice problems. So these first few problems have to do with our exponential function and whether it is a growth or decay function and identifying the y-intercept. So in these first, just remember the base, which in this case is our 0.137, will tell you if the function is growth or decay. Because this is less than 1, right? Between 0 and 1, the base, this is now a decay function. Then the coefficient, that value being multiplied, which is 250, is always the y-intercept. So the y-intercept is 0 to 50. So again, here the base is 1.67, which is now greater than 1. So this is a growth function, but the y-intercept is 0.25. So that's the y-intercept. So 0, 0.25. Then the last one here, the base is 0.6, which is less than 1, making this a decay function, and the y-intercept is 0.70. So then using those pieces, right, which equation best represents this exponential function that's graphed? We'll start with the y-intercept here, and also notice how always read the graph from left to right. So what do you notice here? Well, first off, I do have a y-intercept here at 4 or 0, 4. Then also notice how the graph is showing decay, right? Because it's decreasing. So that means here, my y-intercept needs to be 4. So I know I need to have 4 times something to the x power. So that means I can go ahead and mark off A and D, because these do not have the y-intercept. The base was set to 4, but the y-intercept is 4. So which of these will show a decay function? Well, again, decay is less than 1, so the base has to be less than 1. That's why the answer was B, 1/5. 6 over 5 is greater than 1. Then question 3 and 4, we're practicing converting between our two inverses here. So here, remember, the base is always the base to the exponential. So we have c to the, remember your equation's always equal to the exponent. So that c to the h is equal to b. So that's how you're supposed to convert. So again here, notice how the base is 32 for the exponential. So that means for the log, I need to have base of 32. Then here, remember, right? So we have our log base 32, and then remember the equation was always equal to the exponent. So this log here is equal to m. So log base 32 of y is equal to m. Then this next one here, you're given this situation where we're talking about the value of a car depreciating. So here, this log represents an equation related to this situation. If you wanted to know the specific value of the car, how could you rewrite it? Well, notice how we're solving for V. Now, keep in mind, this is a double-starred question for those who wanted to try it. Well, first off, I need to rewrite this as an exponential, right? So I have my log base 0.8. So the base for the exponential is going to be 0.8. So here, let me erase this. So the exponential is going to be 0.8 raised to the, well, remember, right, the equation was always equal to the exponent, which in this case is t. So we have 0.8 to the t is equal to what? Well, v divided by 17,000. Now notice though, in the end, we are solving for v, but right now v is being divided by 17,000. So then what do you have to do? Multiply, right? Because the opposite of division is multiplication. So we're going to multiply by 17,000. So if you notice, this equation here is equivalent to b if you were to solve for v. So now 4a and 4b, our review on evaluating our logs here. That is not a common log. So if it's not a log with a base 10, then that means we need to use our change of base here. So you need to make sure to set this up as log 27 divided by log base 3. So here, if you put this in the calculator correctly, you should get 3. And then same thing here. Notice how we're looking for the log base 64 of 4. So this is log of 4 divided by log of 64. So now when you put this in the calculator, setting this up, you should end up with C 1/3. And again, remember, right, the base needs to stay in the base, the bottom. So our base here needs to stay in the base in the bottom. So now questions 5 and 6 are the application problems. You bought a used car for $7,500. So that's the initial amount, right? So that's my A sub 0. The value of the car depreciates. So remember, depreciates means decay. We are subtracting. We have a rate of 8.5%. Or remember, right? Move that decimal 2 times to the left or divide by 100. So this rate here is 0.085. What is the value of the car after 4 years? So there's your T. So first off, because we're depreciating, make sure to have subtraction in the parentheses. So A, the final value, is equal to 7,500 times 1 minus, right, not plus because of the depreciating, our rate. So 0.085, and raise that to the T power, which in this case is 4. So putting all that in the calculator, the final value of the car is $5,257 and approximately 9 cents. Then make sure this answer does make sense because the car started at 7,500. So if we're depreciating, it should be losing value, right? So your answer should be less than the original. So it also makes sense. So now question number 6. You have a principal initial amount of $1,600. So again, there's the initial. It's deposited in an account that pays 4% interest or 0.04, right? Move the decimal 2 times or divide by 100. But now notice how this interest is compounded. So we're now, when we have compounded, we have a value for N. And how often is this compounded? Monthly. So that means N is going to be 12. What is the balance after 7 years? So that is your T. Now remember, the formula is like our growth decay model, where you have your initial being multiplied to 1 plus, because we're compounding. Now, instead of just the rate here, now remember, this is your rate divided by that N now. So remember, we have that value of N, but being divided by R. Then remember, we always raise to the T power. But again, with the compound, don't forget to multiply that exponent by also that value of N. So we need to set this up as A is equal to 1,600 times 1 plus our rate 0.04, but divided by 12, because that is your value of N here. Then raise that to the T, which is 7. But again, don't forget to also multiply that by, again, 12 here. So now once you solve this, the final value in the account is approximately $2,000, $2,116.02. Now in these next 2 questions, we're practicing identifying the domain and range. So here, notice with our domain and range, we do have a log function. So this log here, notice how it is constantly going up because it's slowly but surely increasing and constantly going down. So here our range is all reals, or again, negative infinity to infinity. However, the domain is constantly going to the right, yes, but notice how we're not constantly going to the left here because of the asymptote. So notice how that graph is approaching but never reaching at x is equal to 2 here. So that means the domain is not going past that asymptote So all of our x's starting at that value of 2, notice how we're going to the right from there, are greater than 2. So here now with the domain and range of this exponential function, right? Because now notice the equation. So we have an exponential. Well, here our graph is constantly going to the left. And yes, this is going down, but notice how it's getting wider, 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 and it's going on and on. So it's constantly going to the right, slowly but surely. Because we're constantly going to the left, constantly going to the right. This exponential now, the domain is all reals. However, the range, now notice we are constantly going down, but we are not constantly going up because we are approaching this asymptote here. Notice how it's approaching but not reaching now our y value of -1. So we have a horizontal asymptote now at y is equal to -1. So here we've got our y values. Notice how the graph is going down from this asymptote. So y values are all less than -1. So now in our spiral review questions, given this equation, which statement described? Well, we do have the negative on the outside, which is a reflection over the x-axis, so far so good. But remember, anything inside the radical is opposite. So here, this 8 does represent your horizontal, but again, it's not 8. This is a factor of 1/8. So I'm going to mark off A and C. And again, here, this x minus 2 is also on the inside, so this is shifting now to the right 2. Again, opposite, so that's why the answer is B. Now, question number 9, here we have our equation with the 2 cubed roots. But we can't solve this when the 2 are being subtracted, so we need to move this cubed root over. Well, if it's being subtracted, then we're going to add the cubed root here to both sides. So now by canceling out, we have the cubed root. So here, actually, I'll move this. We have the cubed root of 4x minus 9 is now equal to the cubed root of 11 minus x. So now we can raise both sides to the third power. So again, here, raising all to the third, notice how both of the cubed roots cancel out. 4x minus 9 is now equal to 11 minus x. So now notice you're just solving a multi-step equation. So here I need to add x to both sides. I'm going to gather 5x minus 9 is equal to 11. Now we can just continue solving our two-step here. Add 9 to both sides. So now 5x is equal to 20 and divide now by 5. And here you get x is equal to, oops, sorry about that, as I just realized, so our answer wasn't here. So x is equal to 4. So now in question number 10, notice now here how we have our, which of these is equivalent? Well, first off, I do have that negative exponent, so all are showing that we have that fraction, 1 over our radical. And I also notice that this negative is here on the outside, like this is a -1 being multiplied, which means the negative is on the outside. So with that negative needing to be on the outside, then that's why I'm going to mark off C and D, because again, that's like -1. Then now I need to remember, well, if this is h to the 4th power, right, inside of the D radical, because remember that bottom always represents the index. So that's why the answer here is A, because you're talking about h to the 4th power inside of that D radical. And so now simplifying in number 11. Well, notice we're given this expression here, which is equal to y to the b. Well, here we don't know what that new exponent is, right? And this is what this is asking for. This is asking for, if I were to simplify this, what is the new exponent? So we need to go through and first rewrite this. So this is y to the 5, and then inside that third radical, so 5 over 3. Now notice here in the denominator, we have power to a power. Remember, power to a power, right? Think of parentheses. We're now going to multiply. So we need to multiply 7 times 2 thirds. So now this is y to the 14 thirds. Now that I've got my two rational fractions, my rational exponents here, and the same base, we can subtract the exponents. Again, remember, right, top to bottom. So this is 5 thirds minus 14 thirds, which is negative 9 thirds, or which can be simplified to making our new exponent negative 3. Now here, question number 12. It looks a little different, but we're still solving our radical equation, right? Notice how the radical is by itself. So I'm going to go ahead and square both sides. Now the radical goes away. I'm still going to bring everything down. So 2x squared plus x plus 21 is equal to, well, now notice here, right? I do have to do box method because that is x minus 3 times x minus 3. So now I've got x squared, negative 3x, and now positive 9. So this is equal to x squared minus 6x plus 9. However, now we are solving a quadratic, and quadratics have to equal 0. Now I notice I have 2x squared here and just 1x squared here. So I'm going to move everything on this side, the right side, over to get this side equal to 0. Now you could go the other way, but if I were to subtract 2, then I would end up with a negative 1, right? Then that just kind of throws things off when you have a negative leading coefficient. So I'm going to subtract x squared, add 6x, and subtract 9. And then lining up my like terms. So I'm going to subtract x squared, add 6x, and subtract 9. So now all terms cancel out, equal to 0. And now here we go. I've got x squared plus 7x plus 12 now. So now what two factors multiply to get 12? Oops, sorry, as I just realized here, let me rewrite that. What two factors multiply to get 12 and add to get 7? 4 and 3. But notice how we have x is equal to negative 4 and negative 3 here. So now make sure, right, before we say that this is my solution, I need to plug back in to check for my extraneous. Well, here if I've got x minus 3, well, what is negative 4, right? Because that's our x. What is negative 4 minus 3? Well, that's going to give you negative 7, which is a negative value. So here, negative 4 is not a solution. Then here, negative 3 minus 3. Well, that's going to give you negative 6. So negative 3 is also not a solution. So this is a no solution. And so now here with our graphs question, so our first one, notice how this is review with our radical function. So which statement is true? Well, first off, I notice, remember, right, with our radical, this is our half graph. So I need to identify my starting point, which is at 3, negative 2. This is my x, this is my y. Then it's constantly going on in that direction. So here, the values of the function are negative over the interval, negative 5 to 0. Remember, interval is x values. So from negative 5 to 0, which means I'm looking at this portion of the graph. Well, what are those values? Well, if it's above, making them positive, not negative. So A is false. Remember, we're looking for true. So let's keep going. As x approaches infinity, so as I'm going to the right towards positive infinity, we'll notice what's happening to the graph. Boom. It's stopping at what y value? Negative 2, not all the way down to negative infinity, stopping at negative 2. So B is false. So now here, as x is approaching negative infinity, so as we're going to the left to negative infinity, now notice what's happening to our graph. It is going up to positive infinity. So C is our true statement. Now just to show that D is also false. Well, here the domain, we are starting at the x values of 3, but notice what direction is our graph going? It's going to the left here, which is all less than. So that means if the values are less than, then we are actually talking about negative infinity to 3, not 3 to infinity, because that would represent greater than. So D is false. So looking at 14, which statement is false about this cubed root function now? So the domain is negative infinity to infinity, or all reals. So is this true? Yes, because again, constantly going to the left, constantly going to the right. So A is true. The interval of decrease is again over all reals. So again, reading this left to right, notice how we are decreasing, and again, from negative infinity to infinity. So B is also true. The values of the function are positive over the interval 9 to 14. So again, interval again, this is your x values. So from 9 to 14, so keep in mind that this graph, it's continuing on, and notice how the graph is continuing on here. Well, that's below the y-axis, so the values are actually negative, not positive. So this is our false statement. So let's just check though to make sure that D is also true. As x's are approaching negative infinity, so as we're going to the left, right, towards all of our negative values, notice what's happening to the left side of our graph. It is going up to positive infinity, so D is true. So now question 15, writing the equation that shows a vertical stretch by 3. So remember, vertical is outside now. This factor is outside of the radical. So I have that factor of 3, keeping it the same, right? So our factor staying as 3. Then reflection over the y-axis. So now that is a negative, right? But that negative value to show the reflection over the y-axis now needs to be inside of the radical. So negative x, and then here 5 units down. So that means again, up and down, that is outside. So minus 5. So question 16. Notice how here we are dividing. So we are going to subtract, but remember with our square roots, it has the index of 2. Remember, this is the same as y to the 7 over 2 divided by y to the 17 over 2. Now when you subtract, this is 7 over 2 minus 17 over 2. So that's not just negative 10, right? But negative 10 over 2, which is here y to the negative 5. However, we cannot leave that negative exponent. We're going to rewrite it as a positive. So now I have 1 over y to the 5th. Now question 17. Notice here we are multiplying, but the bases are different, so we can't add the exponents. However, we are subtracting, so we can subtract our exponents here. So this is our base of 3, so 3, and that is the whole number 2 minus negative 1/3. So that is again here 2 negatives making a positive. So 2 plus 1/3 is now going to give you 7/3 here. Then here for the base of 5. Again, now see how this base of 5 here is by itself? It is understood then to have that exponent of 1. Because remember, right, 5 to the first power is still 5. So now again, subtracting with our base of 5, 1 being our whole number, minus 10 over 7. Which gives you now, with our base of 5, the exponent of negative 3 over 7. However, notice we have the negative exponent with that base of 5. So here, we're going to keep 3 to the 7/3. Our exponent is still positive. However, to get this exponent now to be positive, we need to reciprocate. So that's why the 5, like it's 1 over 5. So in our denominator, 5 to the 3/7 power.